All right, let's see if we can do this one on shellfish. So this one's a little bit different. All right, it says the links are normal. They give us a mean and a standard deviation. As soon as you have that, this is a multiple choice question. The only thing I'm expecting, is I do expect a little bit of work. So you just take out a sheet of paper or something and do something. And the only work I'm looking at are like Z-scores or even just a normal CDF, just an idea of what you did to get the answer. Ultimately, the A, B, C, D, E is fine. But it has a mean of 10 and a standard deviation of 0.2. So if I started drawing this, I don't need you to draw it. You sure can draw it. Here it says, which of the following is the shortest interval? Now, first of all, before we even think about other stuff, what are we looking at? The shortest interval, if I said I'm going from 9.9 to 10.5, or I'm going from, so those two numbers in green, or I'm going from like 8 to 11. Which one's the shortest interval, the red one or the green one? The red one is. Okay, good. My brain switched all of a sudden. I was like, what? Okay. So yeah, the red one is the shortest one. It's between the two numbers. But here's the issue, okay? We're trying to look on here which one have 4,000 shellfish, and we haven't done one like this. This is an old AP test question, and it says there's a population of 10,000 shellfish. So which one has 4,000 out of the 10,000, which is approximately what percent? 40%. So what it's saying is, which of these, if I go from 0 to 9.949, which would be like way down here. First of all, what's that area? So I'm going to look at that area. We're going to grab our calculator and try this. We're going to go menu 652. We're going to go from 0 to 9.949? The mean is 10 and the standard deviation is 0.2. And here's what it says. It says that would be about 40%. It's 39.93%. If you were to multiply that by the 10,000 shellfish, you would have about 4,000 shellfish. Okay, so right away we might say, well, that's the answer. But the one key in here is what's the shortest interval? So like if I said, well, how long is that? That would be 9.949 long. Because if you subtract them, that's how wide it would be. So I want to check another one. I'm going to check answer C. I'm going to go from 9.7 to 10.2. Because here's one of the rules. To find the shortest amount, anytime you contain the mean, you're going to have a shorter amount because it contains the peak part of the curve. And anything close to the peak has more percentage. Anything out here has less percentage. Does that make sense? So like this one, it has the peak, but it doesn't have both sides. It would only be from here to here. Okay. This one goes from the same number, but further. So I'm going to check part C. So let's try that one. Everybody can grab your calculator and go menu 652, 9.744, I think, to 10.256. And it goes from 10 to 0.2. That one's got actually 80%. It's too big, right? So that one's not it. Now, if you check this one does have 40%, actually. It would be half of this one, if that makes sense. It would be from here to here. And B is going to be a better answer than A because it is shorter. Okay, but let's look at answer D, 9.895 to 10.105. And that one's got 40%. And if you were to take those numbers and subtract That's how wide the interval is. Okay. Yep. Right there. That's the new notes, and the other one is the review. So just grab one of those. You can take those for the next chapter too. All right. So this one actually, if you subtract the numbers that get us 40%, this one's actually the shortest. Okay, so the answer to this one is D. So all I really need is some idea that you use the normal CDF, and we got D as the shortest. Okay. All right, number 2, which is the best definition of standard deviation? We're going to make this one really fast. Okay, standard deviation is an average difference. So it's the average difference from the mean. Okay. All right, so if you got that one's A. There's no real work required for number 2. Number 3, what is the variance? Well, the variance, we had this thing called standard deviation. If you square it, that's called the standard deviation. So the variance is the standard deviation squared. Much faster than number 1. All right, now we've got some pheasants. The mean weight is 1.75. So depending on what you're showing for work, again, my only requirement on your piece of paper is maybe that you draw me a few things, show me how you're thinking it out. Ultimately, the answer, many people might be able to get all the answers without anything. It says standard deviation of 0.42. What percent weigh above 4.84 pounds? Uh-oh. Now look, one is in kilograms, one is in pounds. So since it gave the mean and the standard deviation in kilograms, I'm going to take this 4.84 and I got to convert it to pounds, or to kilograms, I mean. So 4.8 pounds, I know it should be LBS, right? And then there's 1 kilogram for every 2.2 pounds. So if we use this conversion, the pounds will go away. We need to divide by 2.2. 2.18? You said? 4.84. So, okay. So that is 2.2. So what it's saying is, what are your chances you're above 2.2? So if you did this, that to me would be enough work. Now let's find this area. So I'm going to use the shortcut method. This is really kind of what you would want to use on the test anyway if you have this type of question. I'm going from 2.2 to infinity. Now again, infinity can be lots of sevens. That's a really big number. The big number doesn't really matter. Down here, our mean is 1.75, and it said our standard deviation is 0.42. You can calculate the z-score, but you do not have to. So you get 0.142, which is our percent. Now, if you do the z-score, I guess you kind of do need the z-score. I forgot. I think right now the answer is C, because 14% was above. And what's that z-score? That z-score would be 2.2, subtract 1.75, and divide by 0.42. And I get 1.07. So if you had calculated the z-score first, you probably could have answered it. I know there's 2 answers with 1.7, but that area can't be 86%, so you could play the process elimination. So the answer is definitely C. Okay. All right, number 5. Find the percent of values between 14 and 15.2. I'm just going to quickly draw it. I don't need z-scores here. The mean's 15, 14 would be here, 15.2 would be here. We're looking for that area. So let's use the technology. Menu 6, 5, 2. We're going from 14 to 15.2. The mean is 15. The standard deviation is 0.4. Let the calculator do the work. You can use the raw scores. Those are raw scores. You don't need the standard deviation. So it should be 68.5. Now, what you can do is, of course, you can turn this into a z-score. It'd be some negative z-score. You can turn this into a positive z-score by subtracting the mean, divided by the standard deviation, but you don't have to. Okay, everybody, that making sense? Okay, next one. Summary statistics are given. How would you describe the distribution? The two things that you really want to always compare are the mean and the median. Here, the mean is 163.72, and the median, I know it's really small on there, is 163. I figure if my old eyes can read it, your young eyes probably can, at least on your paper, maybe not on the board. Okay, so if anything, the mean is a little bit higher. The mean's the one that gets pulled. So if anything, it's skewed right, but they are about the same, right? So it's either slightly skewed right because the mean is pulled up, or the distribution is symmetric because they're about the same. Those are the answers. So let's, in terms of information, we'll get rid of that one. We'll get rid of skewed left because the mean is higher than the median. So play the elimination game. And then I think right now the answer is D, because I think the mean and the median are about the same. Okay? Let's see what C says. Approximately normal and bell-shaped. I can't tell that from summary statistics. I can't tell if there's a peak. So I have to get rid of that. Skewed to the right, the mean is up. If the mean was higher than the median, then we could have used that one. Okay? So answer for that one is definitely D. All right, 7. Assuming the distribution has a mean of 82 and a standard deviation of 10, what percent would be between 85 and 92? This is just like the other one. We're just looking for a simple percent. So you've got a lower bound in 85 and upper bound in 92. So let's just grab the calculator, let the calculator do the quick work. So everybody, menu 652. If you're on the TI-84, for any students out there working at home, you have to press second vars, which brings up distribution, and then find normal CDF. So anyway, we put in the 85, I think it was, and the 92. And then this is 82 and 10. We jump right to the percent, 22.3. So answer B. A little over halfway. Hopefully we can make it here.
Are you videotaping this?
I am. Yes. So just make sure you don't say your name. It's fine if you talk, but just don't say your name.
The last one didn't say if it was normal.
Oh, good catch. We have to fix this one. And I'm glad you did, right when it said we don't have any information, it's normal. So we just wasted a lot of time. We could have jumped straight to E. It doesn't have enough information. So yes, I am videotaping this. If you came for a review, you can grab a review and the future notes if you want. Those are next chapter's notes. So spread the word too that Friday is, if you know anybody in here, spread the word that it's a blended day, okay? Yep. Feel free to join us. We're on number 8. We just did number 7. We didn't know if it was normal, so it's E. I wasted a lot of time. All right, number 8. Assuming the distribution has a mean of this, standard deviation of this, what percent would be between 72 and 78? Oh, I don't see normal here either. Do you see it? No. Nope. So that one also is A. So glad we had one person on their toes in here to save us a lot of time on this one. And absolutely, it can be on the test. Okay. All right. All right. Here we've got speeds. We've got a mean was, this is supposed to be the mean. So this one, that is supposed to be mean. That's a typo. We're going to take that. So those of you doing that one, It's not meant to be like it's supposed to be the mean there. Okay, so there's a typo. I got to fix the worksheet. Standard deviation 2.3. The graph of the normal plot appears linear. Now remember, the normal probability plot, if it's linear, that means the data is approximately normal, okay? So now we are being told it's normal because they looked at a graph. All right, what would be more unusual, a car traveling 79 or a car going 70? Now it actually doesn't even matter that it's normal because you could do this just based on z-scores alone. So I'm going to take the 79 and I'm going to create a z-score. So I'm going to do this one here. I'm going to go 79 subtract 74.8 divided by 2.3. That's one z-score. That's going to be a positive z-score. The other z-score is 70 subtract 74.8 over 2.3. This one is 5.2 over 2.3. Somebody do that for me. That's 2 point what? 0.9? I cheated. Looked up here. Is that right?
I got one after 2.6.
2.26? Maybe it's not that one then. Oh, 2.26?
Yeah.
Okay.
I got 1.83.
I'll do it on my.
Well, 5.2 2.3 has to be more than 2.
It has to be more than 2, yes.
That could be like 2.6.
Don't doubt my ways, background.
2.26. Well, when I get two students that get different things, that's usually when I jump in and check it. This one would be negative 4.8 divided by 2.3. That's got to be over 2. So that one I bet is the negative 2.09. Is that right?
That's supposed to be 70 minus 79.
70 subtract 74.8.
That's the same. Wait. Oh. Okay.
Come on, get it together.
Okay. 70, 70, 70 minus 74.8.
79 minus 74.8 is
Oh, that's supposed to be 4.2. Okay, so
1.82. Or 1.82.
1.83. So the 1.83 was right again. Same person getting it right. Okay, so which one's more? The idea, which one's more unusual? More unusual is further away. So it's got to be something dealing with the 70. Does that make sense? Okay, 70 is farther away. It doesn't ask for which one is. It just which one's more unusual. More unusual is more standard deviations away. So the answer's got to be 70. So I'm going to play the elimination game. Get rid of B, get rid of D, because that mentions the 279, and I can get rid of E because one of them is more unusual. Now we have to decide. 70 is 2.9 standard deviations above the mean. That can't be right. It was below the mean, right? So the answer's got to be C, and then it actually converts it to a percentage. We could find that percentage, and that percentage would be found by, and the reason we can do the percentage is it is normal, but we can go from negative 999 to 2.03, and I really feel like I'm messing something up. I did. Menu 652, negative 999 to negative 2.23. Is it 23 or 26? What is this one? Is it 2.09 negative?
Yeah.
Okay. 2.09. Well, I feel like none of these are right now. I'm doing something wrong. 70 happens 3.4% of the time. That can't be right. What in the world?
What's the right answer?
70 is more unusual. doesn't happen 3.4% of the time. This happens 1.8% of the time. I don't know. I don't think I have the answer on here. Does somebody see where I'm messing up?
On the answer sheet, it says E.
Oh, it is none of the above are correct. There we go. I crossed that one off too soon. So, sorry for wasting time. None of them are correct because it's mixing and matching all the wrong percentages. Yikes, that one was made me stumble. Okay, so this one, we just have to make a couple z-scores. So, sorry about that one. Leonard scored 36 points on an intelligent test that had an average of 28 with a standard deviation of 3.2. So, figure out that z-score for me. Sheldon did a 12, and the mean was 8, and the standard deviation of 1.2. So this is 2 point something. 2.5. 3.5. What's this one? 3 point something? 3.3? 3? Okay. Answer D. Sheldon was better.
Yay.
All right.
I've been studying for that test. I thought you said there was 10 questions.
There were 13. I thought there were 10 as well. The scores on the previous AP stat test were very low, so Mr. Becker decided to double it and add points. This one I might have a mistake on here. We'll see. The median was 12, so if I were to double it and then add 5, the new median would be 29. So again, look on the answer key because I feel like I had a wrong one on this one. What's the answer key say?
For the median?
For the answer. What's the answer? Which
the
number?
answer is B.
The answer says B. Okay, so we're going to go ahead since the answer key is out there. All right, so the median would be 29, and then it says the first quartile was 8. What's the new standard deviation? So let's see, the standard deviation is 2.4, so standard deviation would be affected by doubling this. The new standard deviation should be 4.8. So I think what has to happen, we have to scribble this out and make it 4.8. I knew I had an error on this one.
Yeah,
Okay.
all the middle ones are scribbled out.
All the middle ones are scribbled out on the answer key. So you can make all the middle ones, whatever, 4.8. And that's why the answer is B. So that one, I still have to fix the worksheet. Sorry. All right. The height is normally distributed, and they have a requirement to be in the top 1.5% of women, which is the shortest height that can get in. So to be in the top 1.5%, this has to be 0.015. So we have to do an inverse norm of 0.985, because remember, inverse norm only does areas to the left. I'm going to finish this last question. So,
Shouldn't it be 2 because it's 98.5?
should be what?
Shouldn't it be 2?
2 what?
2 standard deviations away.
You're thinking of the 0.0015, which is 3 standard deviations away. So it's close. All right.
What is it? Like 1.35 plus the 0.00, or like a 0.0135 and then a 0.00.
The 0.0015 is past 3 standard
Yeah,
deviations.
but I had like the 0.0135 right before that.
No, you have 2.35.
Oh,
Because it's 2.5 is past 2 standard deviations. Okay, so 0.985, going to get this one in. 65 and 2.6. You're on your own on the last one. I'm not going to continue a video in between bells here. So 70.64. So now, if this is 70.64, which of the following is the shortest height? You have to choose that one, 71.